Hi, welcome to the Linux channel. See, when you are working in Linux, kernel space, especially if you are newly started working in the Linux kernel space, you will go through various things. Of course, you will read about kernel internals, data structures, and things like that. So let's imagine you are a little bit well versed in user space. You had been a systems engineering guy or systems programmer, and then now you are venturing into kernel space. See, as you go through the kernel source code, as I often mention, reading books is one part. You will get some basic knowledge, but other than books, it is always advised that you do a code walk and see what is being done in the current kernel code base. And the reason is something you see in the book, it is outdated. Even if it is just a couple of years old, it is too much irrelevant at this point of time, because you will find various changes time to time happening in the kernel source code, which the new APIs or new data structures, APIs, everything will be somewhat different rather than what you read in those books. Or it can be any online tutorials as well, or even my own Linux channel official website, whatever you go through. So time to time, even in my website, I update some sample code, say some of these data structures I time to time update. When I shot these videos, it is 4.x kernel, now it is 6.x kernel. So I do these changes. So as a part of that, you will see these APIs which are exposed externally. So external and internal APIs put in a very weird way in Linux kernel. Hence I thought, let me shoot this video to help your transition from user space to kernel space programming. We have various APIs, then we have those header files. In the header files we mentioned that prototype, and then we include those APIs. So similar thing happens in the kernel as well. There are some few exceptions. So say let's take few APIs. So let me take some APIs which often I use and things like that. So let's take an API, say skp copy, something like this. So this is skbuf is a data structure where it holds the network packets. It's more like a container data structure, and as well as it's a it can be even arranged like a linked list. Okay, so hence you can see there skb copy .c file. You should find its implementation, and then this .h file, it should have that function definition of the prototype. Okay, so you can see over here, yeah, you can see there skb copy, and there are various variants of this skb copy. So you can find there are various variants also can exist. So in this case you can see this is the function, and the function, you will find sometimes even the function documentation, like for example here they documented what is this function, what it does. Sometimes they also document what is the criteria for return and the function arguments, and things like that. So this function can be used anywhere in case you include this header file skbuf.h. Okay, so you can use this function, which is why when we search this identifier here, it shows all these places third party code within the kernel source, they are using this skb copy. So we can take any example, we can open any of this C code, .c file and we should be able to see that they are using this skb copy in this way. You can see their skb copy everywhere they can use in various places. So we can take multiple examples. So these are the regular external APIs which are exposed. So you can see there skb copy, and they are doing this. So this is a regular thing which happens even in user space as well. So these are the regular external APIs. The interesting thing is those internal APIs. So the internal APIs, these external APIs will act sometime like a wrapper API. So it will you will find an API say in this way. So let's imagine that skb copy, let's call it as say my API. So this is the external API. So you can see after that you will have that you will have this thing happening, export symbol. So we have this export symbol, and this will, this is my API. You do something like this, and of course in .h file you will also define that API, of course. So this will have some sort of a return. Let's say this is int, and it is taking some arguments, so say int a, int b, something like that. So the definition or the prototype is going to be int my API and int a, int b, something like this in the .h file. Okay, so this is what happens. So these APIs are like sometimes wrapper APIs, though, so they kind of do something, and then internally sometimes you may find the internally supported logic within that API. Sometimes the logic, instead of within the API, it will be done elsewhere and it will be called within itself. See, sometimes what happens is you will have the logic which is done within the API, but eventually during the course of time this will increase. So they will start adding more and more lines of code, and then it gets slowly even more complicated. So then what happens, again they will extend this, and then they will start adding even more logic like this. So once it goes somewhat out of control, then what they tend to do is they will define some sort of helper APIs. Okay, these helper APIs are the private APIs. Okay, so they will define some sort of helper APIs. So as we know, it will be something like static, and it will have some it may have some return. Let's imagine that is also an int, and sometimes they may call it as API underscore core. The reason is most of the actual logic will be moved into that helper API. So this may take some arguments, and in this function or in this API, okay, so this is not any external API, so this is an helper API. So in this API some of this logic will be moved inside, and this will be somewhat adjusted, and they will be calling this API. So my API core. So from the name you should understand this is an helper API of this function. So you can see there this name is matching. So my API, here also it is my API, and then you will get this name as underscore core. So which means the core functionality of your API, the core functionality of this API called my API has been pushed into this my API underscore core, and that contains the actual complicated full API logic. And this API now more acts like a wrapper API. Sometimes it becomes a situation that it won't have much of any code. So it just hardly has any code, and it will just surround this API. So this becomes more like a wrapper API. And this becomes your helper API. So sometimes like this it will be in a hierarchy. So this I can show you over here inside this net. This in fact I have covered long ago in one episode, but again I thought in this context it's a different topic altogether. It's about these wrapper APIs, external APIs, helper APIs, and things like that. So hope this should help to understand what is the way it's done in the kernel source. Okay, see in the IPv4, in the IP input.c, you have this IP receive API. This is the API, and one point of time there is no such API called IP receive core. Instead, whatever is put logic inside this API, which is this API IP receive core, and you can see there it is defined as static. So it is just an helper API of that IP receive. So this API, the whole of that source code or the logic put inside the API used to exist within this IP receive, and there is no API called IP receive core. So I can also show you, say for example we go to v3 and 3.x kernel, something like that, or even 4.x kernel. It is sometime during 4.x kernel this change happened. So this is one classic example I can show you, because these things do happen very frequently in the kernel source. So let's take 3.7.7 17.7, something like that, and if you go down, you can see IP receive is here and there is no IP receive core, unlike what you saw earlier. Okay, so you can see IP receive and then there is no helper API, and this API used to be this much big, and it has grown over the time. Since it has got bigger and bigger, they felt that we need to split this API and introduce this helper API logic, and then they did this split. Hence you can see there are two APIs. This way, if you do any code walk of kernel source, you should understand that you are not going through hundreds of APIs. Okay, it is just one API. Sometimes you won't believe, even this helper API, if it grows somewhat out of control, then again they will do a split. They will do a split, maybe couple of APIs out of this, and these APIs will be called over here. So they may split this into multiple helper APIs, and those helper APIs will be called within this helper API. So it is like that. Hence it will be keep going on and on and on. You should not get confused that so many things are involved. It is not like that. It's just grown such a way during the course of time. Hence whatever kernel source you are going through looks complicated, but at one point of time it is not. Okay, it's just used to have some minimal code. Now since we are adding more features, say we have network namespaces, we have so many features. So as we add more and more features, these are getting bigger and bigger. Okay, so that is the reason. Whenever there is any pruning happens, any fixing, bug fixing or anything like that happens, the code will tend to become somewhat smaller. Any optimization can happen. Again, the code may get smaller and smaller. But again, once this cycle completes, once again when the cycle starts, it's about adding new features, and then these APIs will grow again bigger. So this happens. The API becomes smaller and then it grows like that actually. So in a way you can visualize in a chart or a graph like this. So it becomes bigger, and then they do some optimization and consolidation, then it becomes somewhat smaller, and then again it grows up, then again they do some optimization, consolidation, then again it becomes bigger. So this happens all the time. Sometimes they may drop any feature which is no longer needed, or something it is replacing some other feature. So at that point of time it may suddenly drop like this, and again this cycle continues actually again. So this is what it is. Hence during this course of time, once it goes out of control, the maintainers or anybody who is taking in charge of that source code will try to do a split, and then again you will find those helper APIs. So that is why this has been converted into two APIs, IP receive into two APIs, and then you can see there are two APIs instead of one API which existed long ago. So this is one case. The other case you will also find in many cases are these underscores actually. So you will find, let's say we search here, underscore, yeah, like this skb pull underscore like that. Again these are helper APIs. Okay, you can see there. You will also find many such APIs in skp core device.c dev.c. Yeah, you can see there it is skb netcore device.c. Here again you will find lot of APIs related to net device data structure, skbuff data structure and things like that. So if you search this underscore, you will find sometimes they are used for variables, sometimes they are used for APIs as well. There are some classic examples. Let me see if I can pick one of them. Okay, so Yeah, you can see there is an API called dev alloc name, and this is an external API. You can see their export symbol. So this you can include elsewhere, provided you include any corresponding header file. You can find the header file quite easily in this online tool. You can see there, as I clicked, it is defined in netdevice.h. Okay, so this is the API which you can include. I mean, this is the header file you can include to use that API when you need in your source code. So you can see the dev alloc name, and this is what it is, and you need this header file you should include. So if you see the implementation of that API, you can see they have provided this documentation, and then you can see there is also an helper API called underscore dev alloc name, and this API is just passing this things into this, and it needs some buffer something, and is allocating that buffer and is passing it into this. Okay, now you should bear in mind this. Now where we are checking is 3.x kernel, not the recent kernel. So let's see how this has been changed in the recent kernels. Okay, so anyway, we will stick to this 3.x kernel. So you can see their alloc name. So in this case, the helper API is not called as underscore core. Instead, it is just called as underscore. So to tone down and to denote that this is just a simple helper API. So you can see their dev alloc name will be somewhere defined. Yeah, you can see underscore dev alloc name, it is defined here, and there are also reasons sometimes that may be used externally, things like that, but in this case it is a pure helper API, and hopefully you should find this static as well. So this is a private helper API, so that is what it is. And since we are going through this source code, which is 3.17.7, what we do is we click this v6.6, and then we see how that API got changed as of now. Okay, so device.c, let me click this. Yeah, you can see there in the recent source code, it's been completely changed. So this is our 6.6, which is like a bleeding edge. So bleeding edge, which means the most recent version. So you can see that here the API looks somewhat different, and here you can see there is a reference of namespace as well. In the 3.x kernel, the namespace thing is quite new, but now it is quite prevalent. Hence you can see even there is an helper API called dev alloc name underscore namespace. So this is looking more like a wrapper API at this point of time, because unlike the old version, this does not have any logic at all. In the old version, you must have noticed, you can even scroll this video and see that API used to have some buffer definition, etc., and then used to call that underscore dev alloc name, but here it is not doing that. So here it is just calling this API, and let's see this API is what. Sometimes now they must have made this helper API as external API also for some reasons. So if you go up, you can see there this API is this API, okay, and that API is calling now this underscore dev alloc name. So you can see there they have introduced something else. So let's put all this together in the 3.17.7 kernel, or we can call it as 3.x kernel. It is like this. So dev alloc name, and then it used to call this underscore dev alloc name. So this used to be the hierarchy. Now what happens is in the 6.6, it is dev alloc name. It is calling dev alloc name underscore namespace. The N stands for namespace. This is nothing but network namespace. So hence you get some context they are passing here, devnet of dev, which will give you the context of that namespace, which is a different data structure pointer. So that they are deriving and passing it here. And if you come up, you will see that dev alloc namespace is containing, this is containing the same kind of source code what you found in 3.x kernel, except this guy is calling this internal helper API, which we found in 3.x kernel. So this is nothing but this. They added a new wrapper for this inside API, and then this is our external API, which is existing in both 6.x and 3.x kernel versions. So this is what it is. Hence these things you should understand. Whenever there is underscore, it is just in helper API. Just imagine that it is again a part of the same API itself. So don't think that you are going through many APIs. It's just part of the same API. At some point of time it is broken down and it is extended. Since you can see here, this is a binding API. Let's see the namespace one. This is not exposed yet outside, so even this is static, and even this is obviously even this is going to be static. So this is what it is. So like this it happens sometimes. When they do the split, they can even call this as number 2 and things like that. So these things you'll find very common. So to summarize, let's understand, you have this external APIs. Sometimes they act like a wrapper APIs because they are wrapper APIs. At the moment you get any split like this, it becomes like a wrapper API. It's just having that name for legacy reasons, then it is going to call something else. And who knows, in the recent kernel as well, we never know, this may get some new code going forward, so we never know. So they tend to maintain this wrapper API for legacy reasons initially, then they may add some more features within this API in case it is required. Okay, hence I am saying again, this is a graph like this, the number of lines added in the source code. So that way we have this external APIs, then we have this helper APIs which will have that underscore core and stuff like that, or in this case it is not like that, it is having this underscore or some sort of naming convention. So that is why we have this helper API. So this is what it is. These things when it comes to user space, it depends on how you architect your source code, but in the kernel we need to most of the times we need to do is reading someone's kernel source, existing kernel source. Hence we need to understand the reason and what is happening, and we need to simplify, not to get confused about this API. So as you do a code walk, just imagine you are doing a code walk, just ignore this. Okay, this is calling this, so let's focus here. This is doing this, but again calling this, so let's ignore this second API as well. So essentially dev alloc name is nothing but underscore dev alloc name. So go to that API wherever it starts, just focus in doing a code walk of this API, and don't focus about those multiple wrapper APIs and those helper APIs. Okay, these are like nested helper APIs, because this guy is calling something for this API. Now this is the wrapper API, okay, and for this API this is the wrapper API. So this is what it is. So this way try to simplify and do a code walk. And whenever I do the code walk, especially whenever I take any sessions, my students gets confused, as sometimes they will be working in some project and then they get confused about these things. Then I try to simplify and give them an approach to kind of cut short, and don't waste time so much in this intermediate helper API. Sometimes this can go further. This guy may call somebody else, this guy may call someone else, and that may contains 3 underscores and dev alloc name, who knows actually. Okay, so things like that. So there's no end to that. Okay, hence you will have many helper APIs, and there are helper APIs for those helper APIs and stuff like that. So whenever you go through this type of complicated things, you just need to leave all these things and then simplify in a certain way, that focus what is exactly happening in the inside most helper APIs, and then come back to the upper APIs. Okay, so this is what is the approach you can do. And luckily, if you have any documentation about these APIs in a book, then it will further help you. And of course, even this documentation will help you, and sometimes you may have even official kernel documentation as well. So when we go here, you have this entire documentation folder. Sometimes you go there and refer about these things. Luckily you may find some documentation about it. So hope this approach is going to help you of your path towards becoming a professional kernel software developer. If you have anything to discuss, be in touch with me, and obviously I do conduct classes as a part of lifetime mentorship. If you are interested, you can inquire and you can join, in case if you are interested getting these things sorted out as quick as possible, and have a proper approach, and simplify these things, and learn things in proper order and stuff like that. So hope you enjoyed this video. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.